With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Prove that the curve y is equals to e raised to the power mod x cannot have a unique tangent line at the point x is equals to 0. Find the angle between the one-sided tangents to the curve at the point x is equals to 0. So what we have to do, we have to prove that the curve which is y is equals to e raised to the power mod x cannot have a unique tangent line at the point x is equals to 0, and also we have to find the angle between the one-sided tangent to the curve at the point x is equals to 0. So first we will write the given curve, that is y is equals to e raised to the power mod x, and we can write, if here it is mod, then we can write e raised to the power x as when x is greater than or equals to 0, and also e raised to the power minus x where x is less than 0. And now to find the slope of this curve, we will differentiate this. So the slope of tangent will be dy by dx will be the differentiation of e raised to the power x is what? E raised to the power x where x is greater than equals to 0, and the differentiation of e raised to the power minus x is what? Minus e raised to the power minus x where x is less than 0. So now if we will understand it with the help of a figure, then this is a graph where this is the x-axis and this is the y-axis, and this side is for the positive curve and this side is for the negative curve, as we have seen that e raised to the power x and e raised to the power minus x, and consider this point as P. So now let us find the value of this differentiation, this slope, after putting the value 0 in place of x. So MT, the RHD will be right hand side differentiation for this. That will be, if we will put 0 in place of x, then something power 0 is 1, and similarly on left side we will put 0 in place of x, we get minus 1. So now here in this figure, if we will draw tangent T1 and T2, so the for this curve the tangent will be like this here, and for second curve the tangent T2 will be like this, where this curve lies on x-axis. So this is the axis. So this is tangent T1 and this is tangent T2. So now let us find the equation of T1 and T2. So equation T1 will be, as we know, the equation of tangent, that is on putting values, and also here the points will be 0, 1 as x is 0 and y will be 1. So on putting values in this equation we get slope is 1, x minus 0, and hence we get the value our equation as y is equals to x plus 1 is the equation of tangent for T1 tangent. And now for T2 it will be y minus 1 is equals to minus 1 x minus 0, that is for the negative side. So we get y is equals to minus x plus 1. So this is the equation of tangent for the second curve. So now if we will see in this graph that this tangent is making an angle of 45 degree, and similarly this angle also make minus 45 degree. So if we will measure this angle from the positive side, then this angle will be something 135 degrees. So here we can see that the both the tangents are perpendicular to each other. So slopes are perpendicular to each other. So we can say that the tangents T1 and T2 are also perpendicular. If slopes are perpendicular, then tangents are also perpendicular, which means that the angle between the tangent is what? That is 90 degree, which means pi by 2. So our answer to this question is what? Option 3, pi by 2.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.